There we go. We'll unmute. Thank you very much, Roger. Can everybody see this okay?
Yes.
It looks fine to me, Ted.
Yep.
All right, great. Well, this talk came out of an experience I had when I was out with my wife Peggy on a very hot desert night. We had pre-pointed several hours before an event, which I thought was going to be a wonderful, relaxing experience. But as the night went on, I noticed that the heat buildup in my camera was actually degrading the image tremendously. So I wanted to talk about how that occurred, why it occurred, how you can avoid that in the future. The first slide goes back to a talk that I gave in 2017 about this PVC-based video camera carrier for telescopes with 2-inch focusers. As most of you know, if you have a strut-based telescope or solid tube Dob, you won't be able to bring your focuser in close enough with a camera to come to focus without shortening the struts or moving the mirror up 2 or 3 inches, which none of us likes to really do. So I came up with this idea of putting together some 2-inch plumbing parts to carry that camera down into the 2-inch focuser close enough to allow it to come to focus. And that's worked very well. And I distributed quite a few of those. But now we've gone to the 3D printing world, and now you can print your own 2-inch camera carrier. If anybody would like the slice file for this, they're welcome to send me an email, and I'll forward it to you. This is exactly the same design as the 2-inch one made out of plumbing parts, but it's 3D printed, and it has the front inch of it or so has been made solid, so that when you drill these holes and thread those little 1/4x20 holes for the set screws, you actually bite into some good solid plastic. So they work pretty well, and they enable you to come to focus in a 12 or 14-inch or 16-inch strut tube Dob with a focal reducer on your camera. There's one telescope, the Skywatcher Dob that has the sliding struts on it. That has a couple of different detent locations on the struts, so you can actually slide the secondary closer to the primary. And in that scope, you don't need a contraption like this. But for most other scopes that don't have that ability, you'll have to use something like this, or move the mirror forward, or buy new struts. So here's what happened. Here's the this is what I saw on the screen after several hours of this camera sitting inside that plastic insulator. Essentially, you can see that there's a huge amount of noise on this camera, and this is a result of heat. We all know already that if you cool your camera sensor, you reduce the noise. But of course, unfortunately, if you heat the camera, you increase the noise, and this is what you see here. And in fact, this mirrors some experience that Bob Anderson had with the little Night Eagle 3 camera that's still in testing mode, where you can see on the right side of the screen there's a heat source that's clearly heating the right side of the sensor more than the left side. And this just makes it much more difficult to pull the event out of the background noise. So this is after 30 minutes of this camera sitting in that little orange plastic carrier running on 12-volt power, which is typically what we use to drive these cameras. I came up with a couple of different approaches. One is that the camera only requires 5 volts DC to run. You can run it on anywhere from 5 to 35, but any supply voltage over 5 volts is simply converted into heat inside the camera during the process of voltage reduction. So my first recommendation is to run that camera on 5 volts DC. How do you do that? Well, several of these lithium battery power sources actually now come with a 5-volt output as well as the 12-volt output. And you can actually order from Amazon a USB to DC power supply cable that will allow you to plug your cable into that 5-volt source and then power your camera on 5 volts DC. So at that point, the camera doesn't have the job of reducing the voltage and turning that extra 7 volts of power into heat in the camera. The other approach was created by Bob Anderson when he did the work on the Night Eagle 3 camera, and that is to apply a heatsink on the back of the camera. And this heatsink is made by DigiKey. It's 20 millimeters square. And I chose to add a drop of thermal paste to the camera and the heatsink. And this simply pulls some of the heat out of the camera and passively radiates it out into the air. And this also reduces the heat buildup inside the camera. In this case, I used a couple of long 2 millimeter screws and a rubber band to keep the heatsink firmly pressed against the back of the camera. It's not perfect, but it does reduce quite a bit of the heat, and the combination of the two does a good job. In addition, I thought, well, why not, see if we could move a little bit of that air inside the camera carrier, because the passive air circulation is sort of restricted. So I put together this little 1-inch fan, a little Raspberry Pi fan. Bought 10 of these on Amazon for a couple of dollars a piece, and just hacked up a little connection for the 5 volts of power, and put this into the back of the carrier, put a little rubber band around it, and it does a nice job of moving the air in and out, and bathing that heat, the fins of that device with moving air. So here's the result. On the left here, you can see the original, and on the right, you can see the background noise almost completely eliminated. The white flashes there are just to convince myself that this was actually a video and not a still picture or just a rectangle. So that's an actual video. You can see the tremendous reduction in the background noise. This is passive active cooling, but not with a thermoelectric cooler, just with a little heat exchanger on the back of the camera, some moving air, and using 5 volts instead of 12 volts to reduce the heat buildup inside the camera. So I've started to use the heat sink all the time. Even when I'm using the camera in the open air, I just put one of those heat sinks on the back, and it just helps keep the heat inside the camera down. I've also started using the 12 volt to 5 volt reduction technique as well. So that was all I had. I wanted to point out that you can do some work to control the heat buildup inside your RunCam cameras, and I recommend that little heat sink as an easy and quick add-on. And if anybody needs some 2 millimeter screws, let me know. I've got hundreds of them left over from the RunCam Night Eagle 2 camera kits, and I'll be glad to drop a few of those in the mail to you.
Ted, is it possible to glue it?
To glue the heat sink onto the back of the camera?
Yeah.
It probably is, but of course the glue might serve as an insulating layer between the back of the camera and the heat sink, which would defeat some of the effectiveness. That's why I chose to use the rubber band approach. I think Bob used fishing line. Anything that will just keep it in good physical contact should be fine. I like the idea of the thermal paste, and it wasn't too messy, so a little dab will do you, as they used to say about Brill cream.
Ed, do you know whether this is a problem with the Wattec cameras?
I was thinking about doing the same experiment on the Wattec camera. I don't know for sure, but I remember that on the Malin cameras, Rock Malin put 4 or 5 of those heatsink things on all sides of his cameras just to keep them as cool as possible. I can't imagine it wouldn't help to some degree to reduce the heat buildup inside the camera. Just sticking those things on every side of the camera, top, bottom, and sides. I don't think there's room on the back because of all the protrusions, but I'm going to try that at home and see if I can't help keep some of the noise level down in that camera as well.
Say, Ted, quick question. Do you have a rough estimate of what ambient temperature is the sort of threshold where this is a useful thing to do?
Putting my finger on the back of the camera, I would say that the back of the camera is probably about 110 degrees Fahrenheit when I start to see things really get bad, like on the left video here. That's just an estimate of like how hot does hot water feel compared to how hot does the back of the camera feel. It's really toasty warm on the camera case, outside the case when you pick it up. And that makes me think the inside could be 120, 130 degrees easily.
Well, I was more wondering about the outside temperature. Like, is this necessary to do in the winter, or is it really only a summertime thing?
I haven't, well, I'm in Arizona, so we don't have winter. But we don't have snow anyway. But yeah, I think it would certainly be a lot less of a concern. But once you embed that camera down inside that orange plastic thing, you really get quite a bit of heat buildup in there, and there's not much air circulation. So if you were using this in the winter and you put a fan on the back of that thing, I don't think you'd probably even need the heat exchanger, but I would use it anyway. And the cooler the camera is, of course, the lower the noise level. So I would say if your camera's out in the open in the winter and you don't see any noise like this, you probably don't have a problem. But those little heat exchangers are cheap, and they probably would help even in the winter just through the passive extraction of heat from the back of the camera.
Thank you.
Can you remind us the size of the heatsink?
It's 20 millimeters square. It's just the right size to fit in the snugly against the back of the Runcam Night Eagle 2 without interfering with the connections. You might have to disconnect the screws from the little bail that serves as a strain relief and move that to another position, but that's easy to do with a little hex 2 millimeter hex key.
So this is Kevin Hartnett. I started occultation observing last autumn with a Runcam, and I have not seen this heat until this summer. I'm in Maryland here at recent observations where I actually saw this glow on the one side of the detector. And it was about at 70 degrees ambient, maybe a little bit warmer. And I do not have the Runcam in one of those sleeves. It's just open air on the back of a Schmidt Cassegrain. So that's been my experience. I haven't really seen, now I get noise, but I haven't seen it this bad. I mean, this looks very much like the noise I got on my last run because of the temperature being so high, just ambient.
It sounds, this is Richard Kelly, also collaborating with Kevin Hartnett on some occultations. And this tip you just gave about going from 12 volts to 5 volts, that sounds, I mean, that's very significant. So that seems like a no-brainer to try next.
Right. Oh, I see a question here from Steve Mester. Do they make thermal tape? They do make a thermal tape. And I thought about using that, but I read online that the thermal tape doesn't conduct heat quite as well as thermal paste. So I just decided to go to the thermal paste and the rubber bands. Plus, the thermal tape, I like the idea that you can take this heat exchanger off if you have to by using rubber bands or fishing line. And but if you wanted to try thermal tape, I think it would certainly be a plus compared to nothing at all especially if you're using one of those orange carriers.
Hey, Ted, George Viscomi. I have noticed the very similar to the image on the left, and I have my Runcam down in a 2-inch PVC, like you've shown. I've been experimenting with a fan, one of those 30 millimeter square fans put up there. And I see a distinct difference in the temperature differences when it's maybe 60 degrees ambient. And I put the camera on and I let it sit for about 30 minutes, and then I switched on the fan, and you could see a noticeable difference in the thermal noise drop just with the fan.
Right, without even a heat sink on the back.
Yeah, I also have those heat sinks, but I haven't tried them yet.
Yeah, and in the desert here, you know, we were at 100 degrees Fahrenheit ambient for most of the night. It dropped down to about 95. So it was pretty warm for us, and it was really warm for the camera. Unfortunately, on that event, that was the one where Roger drove across the entire country. We drove about 250 miles, and we were clouded out 5 minutes before the event after waiting for 3 hours pre-pointed. So we were frustrated, but not as much as Roger was.
I will add here that where I am in northern New York State, our winters tend to get pretty brutal. I'm sometimes observing at 0 degrees Fahrenheit, and I can actually get a magnitude gain of at least 0.3, if not 0.5 magnitudes in the wintertime with the run cam, just because of the cold. As a matter of fact, on really cold nights, I actually put a small cloth in the PVC tube, just because it's 0 degrees or maybe even 10 below zero. So I'm almost afraid the camera is going to get too cold or be exposed to air that's just too cold.
Sure, I've done some of those in Massachusetts at 0 degrees. But that was back with the PC 164 CEX2 cameras.
This is Joan Dunham again. I would think that you would have more trouble with the battery in cold weather than you would with a camera. As we used to have years ago when we observed grazes in cold weather, we used to stuff things into bags and try to put heat sources in and so forth to keep the equipment running long enough to actually record the graze.
Yep, that's right.
Yeah, and those mini DV camcorders, they supposedly go down to 32 degrees, but in fact, it's more like 38 or 39 degrees before they start to have trouble.
Right.
So I've built a little warm box to keep them warm on winter nights.
Okay, that's all I had, Roger. I'll turn it back to you. Stop the sharing here and
Thank you very much. That's very interesting.